Rama has a camel's legs, a llama's ears, and no hump. He weighs 600 pounds, spits when annoyed, and was born in a Dubai laboratory on January 14, 1998. His parents belong to species that diverged 30 million years ago. They live on different continents. One weighs 1,000 pounds, the other weighs 300. Natural mating would have crushed the smaller one. Scientists at the Camel Reproduction Center used artificial insemination. They harvested genetic material from a male dromedary camel and injected it into a female llama. The gestation period lasted 12 months, exactly between a camel's 13 and a llama's 11. Nobody knew if the embryo would survive. Nobody knew what the offspring would look like. The entire project was a guess that happened to work. Rama was the world's first camel, a creature with no evolutionary precedent. His feet were halfway between a camel's broad pads and a llama's cloven hooves. His coat was softer than a camel's, but coarser than the fine llama fiber the scientists had hoped for. He grew larger than any llama, but smaller than any camel. Everything about him landed in the middle, except his personality. 4 more camas followed over the next several years: Camila in 2002, and 3 others whose names never made it into press releases. The goal was commercial. Combine a camel's strength and endurance with a llama's valuable wool. Llama fiber sells for more than sheep wool on textile markets. Camel strength means heavier loads over longer distances. Merge them, and you'd theoretically have an economically valuable animal suited to desert climates. The results were mixed at best. Some camas grew usable fiber. Others produced coats too coarse for textile applications. And Rama himself became a problem. As he matured, he developed a temper that made him dangerous to handle. Camel aggression without llama calm. By some accounts, he was nearly impossible to approach by the time he reached full adulthood. The scientists had hoped for the best traits of both species. They got an unpredictable combination instead. 5 camas, total, ever. The breeding program continues in Dubai, but each attempt requires expensive veterinary intervention with unpredictable outcomes. Artificial insemination in camelids is technically difficult. The success rate is low. And even when it works, the offspring are a gamble. 30 years of effort have produced fewer animals than a single goat could birth in a year. The camel works as a biological proof of concept. Whether it works as anything else remains unclear. Most people have heard of the liger, male lion, female tiger. The hybrid shows up in documentaries and clickbait articles, but most people don't realize how catastrophically large they actually get. Hercules lives at a wildlife preserve in South Carolina called Myrtle Beach Safari. He weighs over 900 pounds. That's more than twice the weight of an average male lion in the wild. He measures 11 feet from nose to tail and stands 4 feet tall at the shoulder. When he rises on his hind legs, he clears 12 feet. He's not just the largest liger currently alive. He's the largest cat of any kind ever recorded in human history. Larger than any wild tiger in any jungle. Larger than any lion that ever roamed the African savanna. Larger than anything feline should reasonably be. And Hercules isn't even the heaviest liger ever documented. That distinction belongs to a liger named Nook, who lived at a wildlife park in Wisconsin and topped 100 pounds at his peak. Nook died in 2007. His weight had destroyed his joints. He spent his final years barely able to walk, his cardiovascular system failing under the strain of moving a body that size. The gigantism comes from a genetic accident called genomic imprinting. In normal lion reproduction, the male passes growth-promoting genes to offspring, while the female passes growth-inhibiting genes. The balance keeps cubs at a manageable size. In normal tiger reproduction, Both parents pass growth-inhibiting genes. Tiger cubs stay smaller than lion cubs at birth. Cross a male lion with a female tiger, and the offspring inherits the lion's growth-promoting genes but lacks the growth-inhibiting genes that would come from a lioness. The tiger mother contributes her own growth-inhibiting genes, but they're calibrated for tiger genetics, not lion ones. The mismatch means the liger has an accelerator for growth and no functional brake. The body just keeps getting bigger. Some ligers have reached 1,400 pounds before their hearts gave out. Their cardiovascular systems can't support bodies that massive. Blood pressure becomes impossible to maintain. Joints deteriorate under weight they weren't designed to carry. Arthritis, mobility problems, and organ failure are common. Most ligers don't live as long as either parent species would in captivity. A lion might reach 20 years in a zoo. A tiger, 25. Ligers often die before 15, their size having shortened their lives. Lions and tigers haven't shared territory in the wild for centuries. The Asiatic lion once ranged across India and the Middle East, overlapping with Bengal tiger habitat. Historical accounts from that era suggest wild ligers may have occasionally existed, but hunting and habitat loss pushed Asiatic lions into a single forest preserve in Gujarat, India, where no tigers live today. Modern ligers are entirely artificial. Every liger alive was deliberately created by humans putting these animals together in enclosures. Every single one was born from human intervention, not natural encounter. Flip the cross, male tiger, female lioness, and you get a tigon. You'd expect a similar animal. You'd be completely wrong in almost every measurable way. Tigons are smaller than ligers, often smaller than either parent species. The genetic imprinting works differently in this direction. The male tiger passes growth-inhibiting genes, and the female lioness passes her own set of growth-inhibiting genes. Both signals tell the body to stay small. Instead of runaway gigantism, tigons stay compact throughout their lives. An adult tigon might weigh 400 pounds, large for any cat, but modest compared to their 900-pound liger cousins. Their appearance leans tiger, faint orange stripes visible against lighter fur, a leaner build, smaller overall frame. Males can grow manes, but they're patchy and thin, nothing like a lion's full ruff. More like a teenager's first attempt at facial hair than a king's crown. The visual impression is of a tiger that's trying to be a lion and not quite succeeding at either. But the real confusion shows in behavior. Tiger instincts demand solitude. Tigers are territorial loners who come together only to mate. Lion instincts want a pride. Lions are social animals that live in groups, hunt cooperatively, and maintain complex hierarchies. The tigon receives both sets of instincts and can't reconcile them. They're anxious around other big cats, but uncomfortable alone. They want company, but don't know how to function within it. Handlers describe them as perpetually unsettled. Female tigons can reproduce, which opens the door to even stranger combinations. Cross a tigon with a lion, and you get a litigon. With a tiger, a titigon. A female liger bred with a male lion produces a liliger. With a male tiger, a teliger. The naming conventions become absurd because the genetics keep cooperating, at least in terms of producing living offspring. Whether those second-generation hybrids are healthy or psychologically stable is more questionable. Each additional cross introduces more genetic confusion. The animals exist because they can, not because anyone has determined they should. Bear Creek Sanctuary in Ontario houses the only 2 jaglions ever documented anywhere in the world. Their names are Jazara and Tsunami. Both are female. Both are healthy. And their origin story involves a hunger strike. Lola was a lioness. Diablo was a jaguar. They arrived at the sanctuary as cubs in the early 2000s, both small enough to need bottle feeding, and the staff raised them in the same enclosure. Standard practice for young animals that will eventually be separated once they reach maturity. Cubs can share space safely. Adult big cats from different species shouldn't. Separation never happened. Every time workers moved them to different enclosures, Lola stopped eating. Completely. 3 days without food. Then 4. The sanctuary relented and brought Diablo back. Lola immediately resumed eating. They tried separation again a few months later with the same result. Lola would rather starve than be apart from Diablo. Eventually, the staff gave up trying. Nobody expected reproduction. Jaguars live in Central and South America. Lions live in Africa. The two species have been geographically separated for at least 2 million years. Their chromosome counts are different. Their mating behaviors are different. Their genetics shouldn't be compatible in any meaningful reproductive sense. In 2006, Lola gave birth anyway. 2 cubs. Part jaguar, part lion. The only jaglions ever documented in history were suddenly living at a Canadian wildlife sanctuary. Their coloring is golden brown, lighter than a jaguar's typically darker coat, with rosette spots distributed across their bodies in jaguar patterns. They have the massive frame of a lion with the muscular density of a jaguar. The most notable feature isn't visible until they bite. Jaguars have the strongest bite force relative to body size of any big cat on Earth, powerful enough to crack sea turtle shells and puncture skulls directly through bone. Lions have sheer mass and raw power. Jazara and Tsunami have both. Their jaw strength is formidable, even by big cat standards. Both jaglions are sterile. Their genetic dead ends with a love story origin. The sanctuary never tried to breed more. Lola and Diablo's relationship was a one-time accident of circumstance and whatever passes for emotion in big cats. The leopon emerged from 19th century curiosity. Breeders in India crossed a male leopard with a female lion just to see what would happen. Documentation from that era is sparse, but the experiments continued into the 20th century. The most famous leopons were bred in Japan at the Koshien Hanshin Park Zoo in the 1950s and 1960s. The result was an animal that looked like a mistake rendered in flesh. The head of a lion on the body of a leopard. Lion-sized frame. Leopard spots scattered across the coat. Males could grow manes, but they were always sparse and patchy compared to pure lions. Nothing majestic about them. Leopons inherited physical capabilities from both parents. They could climb like leopards, scaling trees with surprising ease despite their larger size. They could swim like lions, comfortable in water when most cats avoid it. Their hunting instincts combined elements of both species, the leopard's ambush patience and the lion's power attack. In a hypothetical wild setting, they might have been formidable predators. In captivity, they were curiosities. The Koshien leopons lived 15 to 20 years. All were sterile. All were bred deliberately through careful manipulation of animal enclosures. Nature never put leopards and lions together in circumstances where breeding would occur. Their ranges barely overlap, and even where they do, the species ignore each other reproductively. Every leopon was a human creation, produced to satisfy scientific curiosity and public fascination. No leopons exist in captivity today. Pumapards should be impressive on paper. Puma plus leopard. 2 apex predators from 2 continents merged into a single animal. The reality is disappointing. Pumapards suffer from a condition called hybrid dwarfism. They grow to approximately half the size of either parent species. A puma can weigh 150 pounds. A leopard can reach 200. A pumapard tops out around 60 to 80 pounds at full maturity. Something in the genetic combination triggers a growth limitation that neither species possesses individually. The mechanism isn't fully understood by researchers. The proportions look wrong. A big cat body on undersized legs. Movements that seem awkward and hesitant, like an adult cat trapped in a kitten's frame. They're healthy in the sense that their organs function and they can eat and move normally. But they don't look like apex predators. They look like nature couldn't decide what to make and gave up halfway through the process. A handful of pumapards have been bred throughout history. The first documented ones were created in the early 1900s at European zoos. None exist in captivity today anywhere in the world. The cross produces a viable animal, but not a compelling one. Nobody's trying to make more because there's no scientific or commercial reason to do so. Kekaimalu has lived at Sea Life Park in Hawaii since 1985. She's dark gray, has exactly 66 teeth, and she's the only confirmed wholphin in captivity anywhere on the planet. Her father was a male false killer whale named Ianui Kahe. Her mother was a female Atlantic bottlenose dolphin named Punahele. False killer whales aren't actually whales despite the name. They're the third largest member of the oceanic dolphin family. But they don't typically interact with bottlenose dolphins in ways that lead to mating. In captivity at Sea Life Park, apparently, they did. The calf that emerged was something entirely new to science. Intermediate in size between her parents, larger than a dolphin, smaller than a false killer whale. Dark gray skin, perfectly splitting the difference between her mother's light gray and her father's black coloring. Her dorsal fin shape was midway between a dolphin's curved fin and a false killer whale's more rounded one. Most striking, she had exactly 66 teeth. Bottlenose dolphins have 88 teeth. False killer whales have 44. Kekaimalu has the precise mathematical average. The symmetry seems almost deliberate, though it's purely genetic coincidence. Scientists assumed she would be sterile. Hybrids almost always are. The genetic distance between bottlenose dolphins and false killer whales seemed too great for reproductive viability. The assumption held for nearly 2 decades. Then, in 2004, Kekaimalu gave birth. Her daughter, Kawili Kai, was 3/4 bottlenose dolphin and 1/4 false killer whale. A wholphin born from a wholphin. The hybrid could reproduce. That changed everything scientists thought they knew about cetacean genetics and species boundaries. Kawili Kai is still alive today. So is Kekaimalu, approaching 40 years old. They remain the only confirmed wholphins in captivity anywhere in the world. Wild wholphin sightings have been reported in the Pacific Ocean, but none have been verified with genetic testing. The species, if you can call 2 animals a species, consists of a mother and daughter in a Hawaiian marine park, a population of 2. The narluga was discovered by accident, decades after it died. Sometime in the 1980s, an Inuit subsistence hunter in western Greenland shot what he thought was an unusual-looking whale. It didn't quite look like a narwhal. It didn't quite look like a beluga. The coloring was wrong. The shape was off. The hunter kept the skull as a curiosity. It sat in his possession for years. In the late 1980s, a Danish scientist named Mads Peter Heide Jørgensen heard about the strange skull and obtained it for study. Initial examination was inconclusive. The skull had features of both narwhals and belugas, but matched neither species cleanly. It was filed away in a museum at the Natural History Museum of Denmark and largely forgotten for decades. Years later, with modern DNA sequencing technology available, researchers analyzed the skull properly. The results confirmed what had been suspected. It was a hybrid. Part narwhal, part beluga. A narluga. First-generation cross, with the mother being a narwhal and the father a beluga. Narwhals and belugas are the only two living species in the Monodontidae family. They inhabit overlapping Arctic waters, but have always maintained separate populations. Different migration patterns that keep them apart most of the year. Different social structures. Different feeding behaviors. Narwhals dive deep for Arctic cod and squid. Belugas stay shallower and eat a variety of fish and invertebrates. The species had no obvious biological reason to interbreed. The narluga skull showed teeth that were functionally bizarre. Narwhals have essentially no teeth except for the male's single iconic tusk, which is actually an elongated canine tooth. Belugas have simple, cone-shaped teeth designed for grasping fish. The narluga had spiraled teeth that pointed outward horizontally, as if the tusk-growing genes had activated but produced multiple teeth instead of one tusk. The result was something that looked almost alien. Chemical analysis of the teeth revealed something even stranger. Carbon and nitrogen isotopes preserved in the tooth layers indicated the narluga's diet didn't match either parent species. Narwhals are suction feeders that vacuum up prey. Belugas chase and grab. The narluga, based on isotope signatures, was a bottom feeder. It had developed its own feeding strategy, scraping food from the seafloor with its unusual teeth, a technique distinct from both parents. Scientists don't know how many narlugas exist in Arctic waters. They don't know if the hybrid is fertile or sterile. What they know is that Arctic warming is pushing narwhal and beluga ranges closer together. As ice melts and habitats shift, these species encounter each other more frequently. The grolar bear confirms that hybridization is accelerating on land as well as in the ocean. Polar bears evolved over hundreds of thousands of years to hunt seals on Arctic sea ice. Everything about their anatomy and behavior, white fur for camouflage, enormous paws for walking on ice, ability to swim for days, is adapted to that specific environment. Grizzly bears evolved for a completely different ecological niche, foraging in temperate forests and river systems. The two species rarely met historically. Their ranges barely touched at the margins. Then the ice started melting. The first confirmed wild grolar bear was shot in April 2006 near Sax Harbor in Canada's Northwest Territories. The hunter, Jim Martell from Idaho, thought he had killed a polar bear. He had paid $50,000 for a permit to hunt one. But when he examined the body, something was wrong. The claws were brown, not white. The fur had patches of brown coloring. The face had a grizzly's dish-shaped profile rather than a polar bear's Roman nose. DNA testing conducted afterward confirmed it was a first-generation hybrid. Mother polar bear, father grizzly. Since then, at least 8 more wild growlers have been confirmed through genetic testing, with dozens of additional sightings reported, but not verified with DNA. Second-generation hybrids have been documented. The offspring of growlers breeding with polar bears, or growlers breeding with grizzlies. The hybrids are fertile. They're reproducing in the wild without human intervention. Grolar bears have cream-colored coats that look dirty or stained compared to the pristine white of pure polar bears. Long claws like grizzlies. Humped shoulders. Massive frames that fall somewhere between the two parent species in size. Their behavior is a confused mix that handlers and researchers have documented extensively. Some stomp on objects the way polar bears stomp on ice to break through to sealed dens below. Others forage for berries and roots like grizzlies. They're adapting to an environment that neither pure species is fully equipped to handle. One where sea ice is unreliable and land-based survival is increasingly the only viable option. Some scientists predict grolar bears could eventually dominate regions where polar and grizzly ranges overlap. As the Arctic warms and polar bear habitat disappears, hybrids that can survive on land may have an evolutionary advantage over pure polar bears that can't. It would be evolution by hybridization, happening in real time, driven by human-caused climate change. A new species emerging not over millions of years, but over decades. The zonkey looks like a Photoshop job uploaded by someone who doesn't understand how animals work. Donkey body. Zebra stripes concentrated on the legs. Ears that can't seem to decide which direction to point. It's completely real. Zebras have 44 chromosomes. Donkeys have 62. That mismatch usually prevents viable offspring. Chromosomes need to pair up properly during cell division, and when the numbers don't match, the process fails. Fertilization doesn't work. Embryos don't develop. But occasionally, rarely, the egg develops anyway. The zonkey is what emerges when the unlikely happens. In 2019, a wild zebra in Kenya wandered away from her herd in a wildlife conservancy and into a nearby village. She stayed for weeks, hanging around with local livestock and apparently developing an attachment to a donkey. When she eventually gave birth months later, the foal had stripes. Not full zebra stripes, just bands on the legs and light shadowing on the body. The father was obviously a village donkey. The offspring was obviously a zonkey. The foal became an international news story, though it wasn't unique. In Italy several years earlier, a zebra named Martin at a wildlife preserve became so obsessed with a female donkey named Giada that he jumped the fence between their enclosures to reach her. Their offspring, named Ippo, was born in 2013 and lived as a healthy animal for years, becoming something of a local celebrity. Zonkeys are universally sterile. Everyone has to be bred from scratch. They can't establish self-sustaining populations, but they keep appearing wherever zebras and donkeys share space, which happens more often than you'd expect in African villages near wildlife areas and at facilities worldwide that keep both species. Colonial-era farmers and administrators tried to breed zonkeys deliberately in the late 19th and early 20th centuries. The theory was that zebras resist diseases like sleeping sickness and nagana that kill horses and donkeys across much of Africa. If you could combine zebra disease resistance with donkey temperament and trainability, you'd have the perfect African working animal. The experiments produced zonkeys, but they never scaled. The hybrids were unpredictable in temperament, some calm, some wild and unmanageable, and sterility meant each generation required starting over from scratch. The project was eventually abandoned. The Zorse applies the same concept to horses: larger frame, faster movement, more impressive appearance, zebra stripes overlaid on a horse's powerful body. They were proposed as cavalry animals in the 19th century by military planners who thought the stripes might confuse predators or enemies, and the horse's size would provide power and speed that zebras lack. The reality was an animal that inherited the zebra's wild temperament along with its stripes. Wild zebras are notoriously difficult to train. Thousands of years of domestication made horses tractable and cooperative. 0 years of domestication left zebras as wild and stubborn as their prehistoric ancestors. Zorses got the wild part of the equation. They bucked. They bit. They refused commands. The cavalry project collapsed. Zorses now exist mainly as curiosities at wildlife parks and in private collections, not as working animals. Mules have been working for humans for at least 3,000 years. Male donkey, female horse. So common across so many centuries that nobody considers them exotic or unusual anymore. The Hittites used mules in warfare. George Washington bred them at Mount Vernon. The U.S. Army relied on them for over a century. Mules have 63 chromosomes. The horse's 64 merged imperfectly with the donkey's 62. The odd number should make reproduction impossible. Chromosomes need to pair up evenly during cell division for offspring to be viable. With 63, the math doesn't work. Mules are sterile, except when they're not. Since 1527, more than 60 cases of mules giving birth have been documented in veterinary and agricultural literature. It's rare enough to make news every time it happens, common enough to keep happening across centuries. In 2007, a mule in Colorado named Kate gave birth to a foal that DNA testing confirmed was her biological offspring. The father was a donkey. Kate had somehow produced a viable egg despite having 63 chromosomes. Scientists still don't fully understand the mechanism that allows this occasional exception to occur. Mules are stronger than horses for their size, more sure-footed on rough terrain where horses stumble, more heat-tolerant in hot climates. They eat less food, live longer lives, and require less water. Their hooves are harder and more resistant to disease. The U.S. Army used mules as pack animals from the Revolutionary War through World War II because they outperformed horses in difficult conditions. The Grand Canyon still runs mule trains today because horses can't handle the steep, rocky trails as reliably. The hinny is the forgotten reverse cross, male horse, female donkey. Much rarer than mules because the size difference creates serious problems. A horse stallion is substantially larger than a donkey jenny. Breeding them often produces a foal too large to deliver safely. Pregnancies fail. Deliveries go catastrophically wrong. When hinnies survive birth, they're smaller than mules, have different proportions, longer ears, different body shape, and are notoriously difficult to train. The mule got famous and became a fixture of agriculture and transportation. The hinny got overlooked. Most people don't even know it exists. The coywolf has been spreading across eastern North America for over a century, and most people haven't noticed it, gradually replacing what they thought were ordinary coyotes. Coyotes and wolves diverged roughly 300,000 years ago as separate species. That's recent enough, in evolutionary terms, that their genetics remain compatible for interbreeding. When wolf populations collapsed across the eastern United States in the early 20th century, systematically hunted, trapped, and poisoned into near extinction, the few surviving wolves began breeding with coyotes, expanding into former wolf territory. The result was a hybrid that combined the best survival traits of both parent species. Eastern coyotes, coywolves, are 25 to 30 pounds heavier than their western counterparts. They have larger skulls with more powerful jaws, longer legs for running down prey, wider paws that function better in snow. Their pack behavior is more sophisticated. Western coyotes typically hunt alone or in pairs, taking small prey like rabbits and rodents. Coywolves form organized packs and take down deer. The transformation happened within a century, essentially instantaneous by evolutionary standards. When wolves were common across the East, coyotes stayed out of their territory to avoid being killed. As wolves vanished, coyotes expanded into the vacuum. As they interbred with remaining wolf populations, they evolved, or hybridized, into something new. Today, genetic studies show that eastern coyotes carry significant wolf DNA. Some populations test at 25% wolf ancestry or higher. Millions of coy wolves now live in North America. They thrive in suburbs and urban parks alongside human populations. They eat garbage, pet food, fallen fruit, and occasionally cats and small dogs. They've been documented in every major city on the East Coast, from Boston to New York, to Washington to Atlanta. The coyote in your backyard, if you live in eastern North America, probably isn't pure coyote. It's a hybrid species that's been quietly spreading since your grandparents were young. The wolf dog represents what happens when people try to own something wild without understanding what that actually means. Breeding wolves with domestic dogs produces genetically unpredictable offspring. Some wolf dog pups behave like dogs, trainable, social, comfortable around humans, eager to please. Some behave like wolves, skittish, independent, prone to testing boundaries and asserting dominance in ways domestic dogs don't. Many behave like neither category. They want to be near humans, but can't relax around them. They form bonds, but can't be trusted to behave consistently. They're caught between two sets of instincts that don't combine cleanly. Wolf dogs are banned in multiple states and classified as dangerous wildlife, requiring special permits in others. Ownership is restricted where it's legal at all. When wolf dogs escape or are abandoned, which happens frequently since many owners don't understand what they're taking on when they acquire a wolf hybrid, the animals usually die. They lack true wolf survival instincts and simultaneously lack domestic dog trust in humans. The Savannah cat costs up to $20,000 at the high end and sometimes requires a special permit to own legally, depending on the state. African servals are wild cats native to sub-Saharan Africa. Long legs adapted for seeing over tall grass, spotted coats for camouflage, enormous ears that can detect prey moving underground. They can jump 10 feet straight up to snatch birds out of the air. They are fully wild animals that have never been domesticated in any meaningful sense. Breeding a serval with a domestic cat produces the Savannah: exotic wild appearance, theoretical tameness. F1 Savannahs, first generation, 50% serval genetics, are the most expensive and most challenging to own. They stand up to 18 inches tall at the shoulder. They can weigh 30 pounds or more. They need outdoor enclosures, specialized diets, and owners who understand that they're not really house cats in any behavioral sense. F1 Savannahs retain wild instincts that express themselves constantly. They open doors by learning to manipulate handles. They leap onto refrigerators and high shelves that normal cats couldn't reach. They destroy furniture with an enthusiasm that surprises owners who expected cat behavior. They can be affectionate with their primary owners, but may be aggressive or fearful toward strangers. They're not pets in the normal sense of the word. They're compromises. Wild animals made slightly more manageable through hybridization, but never fully domestic. By the F5 generation, 5 generations removed from the serval ancestor, Savannahs behave more like regular domestic cats. They're smaller, calmer, and legal without special permits in most jurisdictions. But nobody pays $20,000 for a cat that behaves like other cats. The appeal is wildness in a pet-sized package. What owners often get is an animal that's neither wild enough to be fascinating nor tame enough to be easy. The Bengal cat offers the more affordable exotic option for people who want wild-looking pets. Asian leopard cat crossed with domestic tabby. Wild rosette spots distributed across an apartment-sized body. Bengals are legal in most places and popular enough to have official breeding registries, show categories, and established standards. But they're still hybrids, and the wild ancestry shows in daily behavior. Bengals have higher energy levels than typical house cats, stronger prey drive that makes them interested in smaller pets and wildlife, greater intelligence, which manifests as both impressive problem-solving and impressive destruction. They learn to open cabinets, turn on faucets, and defeat child-proof locks that would stop other cats. They need mental stimulation that most cat owners don't expect to provide. Left bored, they make their own entertainment, usually at the expense of furniture, curtains, or anything else they can reach. The beefalo was supposed to revolutionize American beef production when it was developed. It didn't. American bison roamed the Great Plains by the tens of millions before European colonization fundamentally transformed the landscape. Bison survived harsh winters without shelter or supplemental feeding. They didn't overgraze pastures the way domestic cattle do, because their grazing patterns actually benefit grassland ecosystems. Their meat was leaner and lower in fat. Their hides were thicker and more durable. If you could combine bison toughness with cattle docility and established farming practices, you'd theoretically have a better farm animal than either parent species. The first beefalos appeared accidentally in the 1800s when cattle ranchers brought domestic cows into bison territory and the animals bred naturally. The offspring were called catalo originally, cattle-buffalo hybrids. They were fertile and seemed to combine desirable traits from both parents. Interest grew. By the 1970s, deliberate breeding programs were creating beefalos with carefully controlled genetics. Modern beefalos are typically 3/8 bison, 5/8 domestic cattle. That specific ratio balances bison resilience and meat quality with cattle docility and established handling practices. More bison genetics and the animals become difficult to manage. More cattle genetics and they lose the traits that made bison attractive in the first place. Beefalo meat is measurably lower in fat and cholesterol than conventional beef. The animals require less water and less supplemental feeding than cattle. They survive winter without barns or shelter. Consumer demand for conventional beef remained high and stable. Restaurants and grocery stores didn't want to explain what beefalo was to confused customers. The hybrid stayed a niche product, consumed mainly by health-conscious buyers and sustainable agriculture enthusiasts looking for alternatives. About 4 wild beefalo herds still roam parts of the American West, descendants of escaped breeding stock that established feral populations in wilderness areas. They're considered invasive in some regions because they interbreed with wild bison and dilute the genetics of pure bison populations that conservationists are trying to protect. The animals bred to improve agriculture became, in some contexts, a conservation problem. The Dizio has been working across Tibet and Mongolia for centuries without attracting much Western attention. Cross a male yak with a female domestic cow, and you get offspring that are larger than either parent species. They're stronger. They produce more milk. Most importantly, they can work at high altitudes where purebred domestic cattle collapse from the thin air and extreme cold. In the Himalayas, that capability is essential. Female Dizos, called Dzomo, are fertile and can reproduce. Male Dizos are sterile, so herders breed the females back to yaks or domestic cattle to maintain a continuous supply of hybrid working animals generation after generation. The system has been running for thousands of years without interruption. This isn't exotic experimentation or scientific curiosity. It's traditional agriculture that solved a practical problem and kept the solution going. In Tibet, Dizos serve as pack animals on high mountain trails, plow pullers in terraced fields, and reliable milk producers in conditions that would kill regular cattle. They're essential to high-altitude life across the region. Without them, farming in the Himalayas would be significantly harder or impossible in many areas. The hybrid isn't a curiosity there, it's a daily necessity. The Zubron almost replaced cattle across Poland in the 20th century and then vanished almost entirely. Polish scientists developed the breed by crossing domestic cows with Wisent, the European bison, starting in the 1800s and continuing through the 20th century. Zubrons proved immune to many diseases that afflicted regular cattle. They survived harsh Polish winters without shelter or supplemental feeding. They were physically stronger than cows, but more docile than wild bison. After World War I devastated Poland's agricultural sector, scientists proposed Zubrons as a solution for rebuilding. Breeding programs ramped up with government support. Zubrons spread across Polish farms throughout the mid-20th century. They seemed like the future of Eastern European livestock. Then, the economy collapsed in the 1980s. Agricultural funding evaporated as the country's finances crumbled. The breeding programs shut down. The Zubron herds were dispersed, sold off, or slaughtered. Today, a single herd of approximately 12 animals lives at Białowieski National Park in Poland. That's the entire species. 12 animals in one protected forest. The future of Polish agriculture became a footnote. The Jeep violates basic genetic rules and appears anyway, occasionally, against all expectations. Sheep have 54 chromosomes. Goats have 60. The numbers don't match up properly. When sheep and goats breed, which they occasionally do when kept in the same pasture by farmers who don't think to separate them, the offspring almost always die before birth. The embryos fail to develop properly. The ones that survive a few days after birth typically die shortly afterward. The genetic incompatibility is supposed to be absolute and insurmountable, but occasionally one survives. A Jeep. Sheep wool on a goat-shaped body. Confused behavior that doesn't cleanly match either parent species. A living exception to rules that geneticists considered firm. Natural Jeeps are distinct from chimeras, which laboratories create by physically fusing sheep and goat embryos together at early stages of development. Chimeras have cells from both species mixed throughout their bodies in patches. Jeeps are true hybrids. Each of their cells contains combined sheep-goat genetic material from actual fertilization and reproduction. They're rare enough that each documented birth makes international news. They're healthy enough to live normal lifespans once they survive infancy. They exist despite everything that says they shouldn't be possible. Killer bees number in the millions across 2 continents and keep expanding their range northward every year. In 1956, Brazilian scientist Warwick Kerr imported African honeybees to crossbreed with European honeybees that had been brought to South America by colonists. The goal was practical: create a bee better suited to tropical climates that would produce more honey in Brazil's heat. European bees had evolved in temperate regions and didn't thrive in warm, humid conditions. The experiment worked exactly as intended in some ways. The African genetics produced bees that were more active, more productive, and more viable in warm tropical environments. What Kerr didn't fully anticipate was the defensive aggression that came along with those beneficial traits. African honeybees evolved to defend their hives against predators that European bees never faced, including honey badgers and other aggressive mammals. Their defensive behavior is extreme compared to European bees. They attack in much larger numbers when disturbed. They pursue perceived threats much farther from the hive. They sting more times before giving up the attack. In 1957, 26 swarms escaped Kerr's research facility through an accident involving removed queen excluders. Those escaped bees bred with local European bee populations across Brazil. Their hybrid offspring inherited the aggressive defensive traits from the African side. Africanized bees, killer bees in popular terminology, have been expanding their range ever since. They moved through South America over decades. Moullards don't occur naturally anywhere. Every single one requires artificial insemination because Pekin ducks and Muscovy ducks belong to different genera and don't mate on their own even when kept together. Despite this, millions are produced annually by the poultry industry. Moulards grow larger than either parent species and accumulate fat much more efficiently. The liver swells substantially. The meat is rich and tender. Approximately 90% of foie gras production worldwide depends on Mullard ducks because their livers grow bigger and faster than other breeds. The Mullard isn't a species in any natural sense. It's a product, an industrial input bred specifically for a culinary purpose through repeated artificial intervention. Every bird is created from scratch because the biology doesn't allow for natural reproduction or self-perpetuation. Iron Age pigs were bred specifically for visual accuracy on historical film sets. Modern domestic pigs have been selectively bred for meat production for so many generations that they look nothing like their wild ancestors or medieval predecessors. They're pink, barrel-shaped, floppy-eared, and behaviorally docile. Wild boars, their ancestors, are lean, bristly, dark-colored, and genuinely dangerous. When historical dramas need pigs that look like they belong in a medieval or ancient setting, they need something between these visual extremes. The Iron Age pig was bred by crossing wild boar with Tamworth pigs, a heritage breed that still retains some ancestral features like reddish-brown coloring, upright ears, and a leaner body shape. The result is an animal that looks appropriately primitive and historical, but is behaviorally calm enough to work around film crews without causing problems. Iron Age pigs appear in period productions across Europe whenever authenticity matters. They're not a commercial livestock breed in any meaningful sense. They're actors, props with hooves and snouts, bred specifically to look old-fashioned on camera. The struttlefish revealed that species separated for 184 million years can apparently still hybridize, which surprised everyone involved. In 2020, Hungarian scientists at the Research Institute for Fisheries and Aquaculture were attempting to reproduce Russian sturgeon using a technique called gynogenesis. Normally, sperm fertilizes eggs by contributing genetic material from the father. In gynogenesis, sperm triggers egg development without actually contributing DNA. The offspring are essentially clones of the mother. The researchers used American paddlefish sperm because they assumed it would trigger the development process, but couldn't actually fertilize sturgeon eggs due to genetic incompatibility. The two species last shared a common ancestor approximately 184 million years ago, before the dinosaurs dominated Earth. They live on opposite sides of the planet, one native to Russian rivers, the other to the Mississippi River basin. Hybridization was considered genetically impossible by everyone familiar with both species. It wasn't impossible. The paddlefish sperm fertilized the sturgeon eggs. The offspring inherited visible traits from both parent species. Some looked more like sturgeon. Some looked more like paddlefish. The scientists published their findings in the journal Genes, with what can only be described as scientific bewilderment evident in the writing. They hadn't intended to create a new hybrid species. They were doing routine laboratory reproduction work and accidentally crossed two fish that diverged before dinosaurs walked the Earth. The struttlefish proves that the rules geneticists assumed about species compatibility are more flexible than anyone previously believed. Rama the Kama in Dubai, Hercules the liger in South Carolina, Kekaimalu the wholphin in Hawaii, Jazara and Tsunami the jaglions in Ontario, millions of coywolves across eastern North America, millions of killer bees across 2 continents, a handful of pumapards that barely reached adulthood, a dozen zoobrons in one Polish forest. Some were laboratory experiments with commercial goals. Some were accidents on farms where animals shared space nobody thought to separate. Some are showing up wild because climate change is pushing species into ranges that evolution kept separate for millions of years. Grolars are breeding in the Arctic right now. Narlugas are swimming in warming Arctic seas. Coywolves are raising pups in suburban backyards across the entire East Coast. The crosses keep working, even when genetics says they shouldn't. 27 animals on this list. 27 exceptions to rules that were supposed to be absolute. 27 demonstrations that species boundaries are blurrier than biology textbooks suggest. The next hybrid might already be out there. Swimming. Out there. Swimming. Hunting. Breeding. Waiting to be found by someone who knows what they're looking at. Hit subscribe. More coming.